Hello friends, very good morning. So here in this lecture we are about to discuss about dielectrics. What is a dielectric material and how it works? How many kinds of dielectric materials are there? So basically we know that materials are basically of two types. One is conducting and second one is non-conducting. Uh, then what is dielectric? Is this an third kind of element? Then you can say it is yes, it is a third kind of element which acts as a conducting as well as a non-conducting materials. Then how, what are the properties of dielectrics and how it works? So we can explain or define dielectric material as a material which acts like a conductor and after some limiting value, and as an insulator within some limiting value. So dielectrics have a limiting value which is also known as dielectric strength. So any dielectric material acts as a conductor after its limiting value and as an insulator or non-conductor within its limiting value. So first of all we are here to discuss how many types of dielectrics. So dielectric materials can be categorized of two types, that is polar dielectrics and non-polar dielectrics. So what are the basic differences between these two types of dielectrics, whether it is polar or non-polar? So if we talk about polar dielectric material, so in polar dielectrics materials the positive and negative centers of any polar molecule does not coincide. Means we can say their positive and negative centers are separated by some distance. So a polar molecule, we are here considering about polar molecule and polar molecule together form a polar dielectric material. So when we are talking about polar molecule, in polar molecules their positive and negative center are not coincide, that they are separated by a certain distances. That's why a polar molecule has a net electric dipole moment in the even in the absence of electric field. Uh, uh, Listen everything carefully, whatever I want to say. I am saying that a polar molecule have a net electric dipole moment non-zero even in the absence of external electric field. It is why it is because of their positive and negative centers separate. But when we talk about a polar dielectric material, it has no permanent dipole moment in the electric absence of electric field. Polar molecules have net dipole moment even in the absence of external electric field, but a polar dielectric material do not have. It is because in the absence of external electric field, polar molecules are randomly oriented. That is, their positive and negative directions are not fixed, but instead they are oriented in random directions. That's why a polar dielectric material has net electric dipole moment 0 in the absence of electric field. But when we apply some external electric field to any polar dielectric material, the centers of positive and negative centers of each polar molecule coincide in a definite direction. That is, positive centers are directed towards the electric field while negative centers are directed in the opposite direction of electric field. That's why now the polar dielectric which contains these polar molecules have a permanent dipole moment. So this is how polar dielectric works, and what are the effect applying external electric field, and what are the basic examples of polar dielectric, which is ammonia and water. So ammonia and water are the two basic examples of polar dielectric materials. Now when we talk about non-polar dielectric materials, so non-polar dielectric materials are those materials which have their positive and negative centers coincide. Like when we are seeing here, their positive and negative centers are coincide, means uh, both positive and negative centers at a same time. That's why they are neglecting each other, and we are making here no sense of positive or negative. In the absence of magnetic external magnetic field, their positive and negative centers are coincide. But when we are applying an external magnetic field to non-polar molecule, then their negative and positive centers shifted here. Consider now what happens. Positive centers are shifted towards in the direction of external electric field, while negative center shifts in the opposite direction of external electric field. So these are positive centers, and here in opposite direction negative centers. Now we can see some separation between these two charges, while in first case there is no separation, means they are coincide. So now as the positive and negative centers now are not coincide, they are separated. So a net dielectric moment produced in this, and this is called induced dielectric or induced dielectric moment. So these are the basic examples of non-polar dielectrics, and are benzene and methane. So we talked about two types of dielectric material, and about dielectric strength, what is the limiting value of any dielectric material, and about polar dielectrics material and polar molecules, and also about non-polar dielectrics and non-polar molecules. That's all. Thank you.